Alright guys, in this video we will discuss what it means to be an even or odd function. So let's go ahead and get started. So we're going to start out with a couple of definitions. So in order for a function to be an even, it is a function whose graph is symmetric with respect to the y-axis. So I'll show you a drawing of that here in just a second. But really we can go ahead and jump and say that basically what this means, guys, is that if you have a point x comma y, you also have the point x comma negative y. Okay, uh, I'll further explain this in just a second. An odd function is a function whose graph is symmetric with respect to the origin. So that one's a little trickier, but here's really what it means. That means if you have the point xy, you also have the point negative x, negative y. Okay, so what does this mean graphically? So first of all, let's say we have a graph. Here's your x and y axis. So let's say that you have something like this. Okay, notice for example that I have this point right here. Based on what I have here, I have the point 2, 1, and notice how here I have the point 2, negative 1. So that would be that the function is even. Now I didn't draw this perfectly, but you can see that if you were to fold along the y-axis, the left and the right hand side would match. So this would be symmetric with respect to the y-axis, therefore it would be considered an even function. Okay. Now, what would it mean to be an odd function? So here we go. Let's do an x and a y-axis once again. X-axis, my y-axis. So maybe something along this. Let's say. Try a little bit more. Something like that. Notice how I have this point right again. I'm just trying to at least show you one point. So I have the point right here, 2, 2. But I also have the point right here, negative 2, negative 2. Then because this is happening, notice how this is what was previously mentioned in the definition. This would be considered an odd function. Now this is where students have the most trouble with, especially visually. But let me go ahead and give you kind of like a shortcut that I use. Okay, so for this one we said it was symmetric with respect to the y-axis. That's pretty simple for a student to see. Now, what does it mean to be symmetric with respect to the origin? Because the origin is just a point. Now, watch the paper very closely. Look how this is graphed. Okay, to be symmetric with respect to a point, you basically have to flip your paper 180 degrees. So I'm going to go ahead and do that. Watch the paper and look how it looks exactly the same after I flip. So 180 degrees there. Notice how the graph still looks the same. Okay, if you were to rotate your paper 180 degrees and the graph still looks the same, that is the way to test whether or not your function was odd. Okay, and lastly, if neither one of these things work, then it is considered to be that the function is neither even nor odd. Okay, now for homework, you're going to have several examples where graphically they're going to ask you, like, look at this graph. Can you tell whether the function is even, odd, or neither? And I think, and honestly, I don't think you need a lot of examples. I think this should suffice, and you should be able to successfully tell whether a function is even or odd graphically. All right, now let's go ahead and discuss how we can do this algebraically. Okay, so let's say that you have the following. It says testing for odd or even functions algebraically. So a function is considered to be even when f of negative x is equal to f of x, and a function is odd when f of negative x is equal to negative f of x. So here's what it means, guys. You're going to be given a function. So I'm going to do an example with you. You're going to be given a function. You're basically going to be asked to introduce negative x. Okay, so in other words, evaluate a negative x. If you plug in negative x into the function and you get back the original function, then it is considered to be even. But if you plug in negative x and you get the negative of the original function, then it would be considered to be odd. If that doesn't happen, then it's going to be neither. So let's go ahead and try it. So what is f of negative x? So I'm going to plug in negative x for x. So this would be negative x to the third power minus, and I'm going to plug in negative x. So we got to clean this up. So f of negative x. Okay, so what's negative x to the third power? Well, negative x times negative x times negative x would be negative x to the third power. And negative times negative would be positive, so plus x. So what I want you to notice is, technically, you don't have to write this, but if I factor out a negative from here, Notice how I get back the original function, but with a negative in front. Therefore, the function of f of x would be what we call an odd function. Okay, so let's kind of recap. So you've got to plug in negative x for every x, evaluate and simplify, and just compare. Do you get the original function back, or do you get the negative of that function? And if that doesn't happen, then it's going to be neither. Okay, let's try another one. Okay, so let's say that we have x to the fourth plus 2x squared minus 1. So once again, we are going to plug in negative x. So negative x for your x value. So we're going to continue to simplify. Okay, what's negative x to the fourth power? That would be negative x times negative x times negative x times negative x, which would give you a positive x to the fourth power. If I multiply this in, well, negative x squared, that's going to give you positive x squared times 2. That would be plus 2x squared minus 1. Notice how the evaluation gave you back exactly what you started with. Therefore, this would be considered an even function. Okay, one last one. Let's say we have x to the fourth plus x to the third, y equals x to the fourth plus x to the third plus 2x squared minus 1. Well, let's go ahead and evaluate at negative x. So I can put negative x for every x value. Okay, so negative x to the fourth power would be x to the fourth power. Negative x to the third power would be negative x to the third power. Negative x squared would be positive times 2 would be positive to 2x squared minus 1. So notice how this stayed the same, this stayed the same, this stayed the same. However, this changed. Because not everything stayed the same or not everything switched sign, it's not going to be that's sufficient for us to say that it's neither. Okay, so it's not even, it's not odd. Okay, now let me give you one little trick to kind of show you also kind of how you can check your work. Now, if you're in my class, I'm going to ask you to show all this algebraic work. However, there is a trick you can use to just look at a function and determine whether it's even or odd. Okay, now let's look at these two examples that I just covered. Notice the powers. Okay, notice how the power here is even. Okay, technically this is to the power of 0, right? It's like having an x to the power of 0. Okay, if absolutely all of your powers, absolutely all of them are even, and you have a 0, or you don't have to have a 0, like if just you only have even powers, but you also happen to have a 0, then that's enough just to look at it to say that it's even. Okay, if you have a mixture of powers like this one, you can automatically say this is going to be neither. Okay, if I go back to the previous example, notice how all of the powers, so this is power of 3 and this is technically a power of 1. If all of the powers are odd, then you're going to have an odd function. However, let's go back and pretend I had this as, I don't know, plus 1. Notice that if I have plus 1 in here, it's going to change into a minus 1, which would then at that point mean that not everything changed values. So with odd, if you're going to use a shortcut, you have to be very, very careful. You cannot have a constant. All of the terms have to have an odd power, and then it's enough for you to say it's odd. If it has a constant, then automatically you can say that it's neither. Okay, so hopefully that shortcut maybe helps you at least check your answers. And lastly, before I end this video, a lot of students typically ask me, and I always ask myself this, I've been teaching this forever, why is there such an emphasis on you guys knowing whether a function is even or odd? So later on in mathematics, and this is really for those of you that are maybe going into certain careers, and honestly, to be completely honest with you, this is mainly just important for people that are going to be mathematicians. It's really not that big of a deal with other things. This really can help you later on in calculus, saving some work when you're doing integration, or even maybe when you're doing Fourier transforms. You have no idea what that means. You'll get to that way later on in your math career if you decide to. But to be completely honest with you, this is one of those things that sometimes like it is puzzling as to why we have such an emphasis on it. However, I do think it's pretty cool to see the bridge between geometry and algebra. That's really where this all comes through, being able to see geometrically what's happening and make that connection with algebra. But anyways, I always kind of like to tell you why you learn certain things. I hope you enjoy the video, and I will see you next time.